They use 40% of the world's energy, emit 50% of its greenhouse gases. They are not the cars we drive. They are the buildings where we work, live, and grow. Buildings designed with an unconscious disregard for nature. Adopting sustainable alternatives is not only a matter of progress, it's a matter of survival. Design E squared, the economies of being environmentally conscious. Buckminster Fuller once said, "I look for what needs to be done. After all, that's how the universe designs itself." With more people living on Earth than ever before, the planet has never been under such stress. How can we live in harmony with our Earth? We must transform the way we think and act, introduce ourselves to new worlds, worlds of three visionaries who realize there's no time like the future. Wind, rain, and sun. To the mind of most architects, they are the enemy. But what if buildings could respond and utilize the conditions of their environment? What if the urban environment itself became a living, breathing organism? To Ken Yang, it is.
I started work on the idea of bionics, I think, in 1971. I started looking into ways human beings imitate nature. And so one of the things I studied at the time was the idea of the prosthetic device. So you have prosthetic arms, you have prosthetic kneecaps, you have prosthetic hip joints, you have prosthetic hearts, and so forth. And what occurred to me is that the prosthetic device has to integrate with a host, organic host body, which is the human body. And then it occurred to me that in a similar way, that everything that we build are equivalent to prosthetic devices, and our host organism for our built environment is the Earth, is the biosphere. And the successful integration is the eventual success of the Earth in a green future.
For the Singapore Library, Yang's use of bioclimatic design showed that a structure could not only benefit humans, but also indigenous plants and animals, resulting in a benefit for all.
We had some 40 expressions of interest when we first started the project. 6 were finally selected to actually create a pitch as well as a design, a competition perspective. And from that, we actually chose Ken Yang to be the architect of design here. And I remember when I first met him and when I asked him, how are you going to make a building that will meet users' requirements? He says, well, I can do that. I would also like to make a building that is actually green and stands its test of time. But at the same time, you can make the building look nice because the users would like to have the building look nice as well.
Designing with climate is really low-tech design. But in the 60s, energy became so cheap. So architects could basically build and design whatever he wanted and create whatever forms he wanted and forget about climate. Who cares, because we could just use up more energy and air condition the whole place or heat it up a little bit more in winter. So looking at traditional systems that people have been using intuitively, but we forget. So there are many of these low-tech systems which need to be revived, restudied and reinvented for contemporary users. And so these are some of the systems that I'm looking at, actually experimenting with in my work. In many ways, architecture is trying to achieve a fit between the site constraints and the client's requirements with what you propose to design. And so the more technology, the more systems that we have, the greater would be the fit. And so the objective was to be as fine a fit as possible.
We've been involved right from the start when Ken was just sketching out ideas as to how the building should look. And he said, how can we really incorporate your technology into my design so that I don't see anything, so that it just looks like a really fantastic building? In terms of intelligent design and intelligent facade, it's way ahead of its time. In terms of what we're controlling inside, of all of the mechanical and electrical systems, the air conditioning, it's pretty well state-of-the-art. All of the technology in a building that you might call intelligent or smart should be invisible. And the people that are managing, owning, or occupying the buildings should not be aware of all the technology that's there controlling the environment. I mean, there's examples of where you can use automatic shading, automatic glass that sort of tints to reduce the glare in a room or reduce the energy consumption. And all of these things are getting to be invisible to the user. And for instance, a very obvious one is the fact that the escalators here stop automatically if there's no one on them. And they start again when people approach. So there's a big energy saving there, an obvious one, but a very practical one too. We can save up to 80% of the energy that a building uses by intelligent, clever design, by integrating all of those functions. You can save a lot of energy in a building.
Now, for instance, the idea of having these what are called light shelves is low tech. You know, it's a way of throwing light into the inside of the building. And so by doing this, you reduce the need for artificial lighting.
It means that only for 50 minutes during the whole day, direct sunlight might touch some of the spaces in the building where people might be using it. But even that was thought through, because in those 50 minutes, automatic blinds will come down. And so therefore, it's a very comfortable environment for the user throughout the day itself. And where you don't need lighting to be put on during the day itself, it's natural lighting that does it. Once again, you save operating funds. So all these things that we have to wrestle with: architectural, engineering, orientation, people's wishes, building planning conditions. And it costs actually less than it started off with, which is quite delightful.
If you notice that the building it has this ventilating shaft in between. You know, this atrium, which is between the collections block and the programming block, is actually a non-air conditioned space. But by doing this, we create a ventilating shaft here, so the wind can go all the way up. And top of the building there is a roof which is not, well, it's not semi-perforated, it has louvers, so the hot air doesn't accumulate on top, it goes all the way out. So wind goes below, it goes in between, it goes on top. So in this way, we increase the surface area of the building to enhance its natural ventilation and to try and cool the building, you know, to reduce the energy required to air condition the building. So in this way, the building really is a tropical building, which is not just tropical in the way it relates to the climate place, but it's also a building where people experience the climate as they walk towards the building and into the building.
There are actually 14 gardens spread out within the spaces of the building, and only one of those gardens actually, or two of those gardens are actually on the ground up. The rest of them are scattered all throughout the building itself. So it does create an environment of greenery as you are in the library to do whatever you do in the library.
The spaces are really social zones for people to come from the outside and to go, you know, from the inside and go outside and enjoy the space and enjoy the climate really and enjoy the vegetation. If we could, actually, we should try and recreate the ecology of the location before it was, you know, devastated by human beings. It's the first step in integrating the natural with the human-made. You know, the next stage is to systemically integrate it, and then to make use of rainwater harvesting, is to make even, you know, the walls grow if we can. See, nature existed in a state of symbiosis, a stasis, before we human beings started to disrupt nature. And so what we've done is that we've disrupted the cycles in nature, the processes in nature. And so what we should try and do is to bring as much organic components as possible into the built environment, to integrate the two together. And so integration to me is the single greatest issue that we have to address as green designers. If we're able to integrate everything that we do in our built environment with the natural environment, then there won't be any environmental problems at all. But I think the green building of the future will be totally different. How to integrate the systems and the materials with the ecological systems in the biosphere calls for total rethinking and re-examining of how we put buildings together. Everything in nature is connected, you know, either physically or climatically. The whole world is connected, if you like.
So if everything is connected, can we transform the world through ecologically intelligent design? To architect William McDonough, we must not only embrace new philosophies, but also innovative business strategies to reshape the world economy. His co-authored book, Cradle to Cradle, looks at how goods and services can generate not only economic value, but also ecological and social value.
The problem with recycling as we conventionally practice it or characterize it is that in most cases it's really what we've characterized as downcycling. The materials are losing their quality as they go through the system. We're calling for what we call upcycling. So it's either true recycling or even getting the product better. A bottle, for example, take a look at this bottle. This is polyester terephthalate. It contains antimony, which is a toxic heavy metal, as a result of catalytic reaction, the catalyst that is used. This is idiotic because I don't need antimony in this bottle, and it's a beautiful material and can be infinitely reused. But right now, this will go off and become a park bench. It won't be reused as this, plus it's got this slightly toxic material. It doesn't affect you drinking the water, but it does affect the whole system. The system is contaminated by a carcinogen, which is just bad design. It's totally unnecessary. In order to be a living thing, you have to have growth, you have to have free energy from sunlight, and you have to have an open system of chemicals operating for the benefit of the organism and its reproduction. So what Dr. Michael Braungart and I are looking at with Cradle to Cradle is the idea that human artifice could follow the laws of life itself. And we would need growth, free energy from sunlight, and an open system of chemicals that are safe and healthy. So the real question becomes, when do we find ourselves in kinship with the natural world? When do we find ourselves as part of the natural world? And that's why Cradle to Cradle is so important. In nature, nature is not efficient. It's effective. So a cherry tree in the spring is not very efficient. Thousands of blossoms so you can get one tree to reproduce. It's not that interesting as far as efficiency goes, but it's magnificently effective. So we're looking at both human technology in terms of our comfort and our ability to thrive as a species, but also how would we integrate that into the natural world without destroying it? That's a fundamental question that we haven't asked as a species. We become part of the human resource of the natural world instead of simply seeing nature as natural resources of the human world. Well, Cradle to Cradle is a simple, commonsensical approach which says things either go back to soil safely and forever, or back to industry safely and forever. So we design products that we're going to end up in the dirt, like a paper plate. Why not design that with a little nitrogen in it so when you throw it away, the farmers want it? If we look at the products like cars or computers, those are things that want to go back to being cars and computers. So right now they become toxic waste. Why couldn't they go back into closed cycles? We see this happening as a small part of something really huge that's pretty much out of control.
Design today must reflect a new spirit. By employing the intelligence of natural systems, we can create industry, buildings, even regional plans that see nature and commerce not as mutually exclusive, but mutually coexisting.
The first industrial revolution was an aggregation of a lot of individual acts based on specific opportunity. It wasn't designed as a whole system. And now that we've seen the result of the whole system of the first industrial revolution based on brute force and the use of fossil fuels, we should stop, take a breath, or try to anyway, and say, wait a minute, was this designed? Was it our intention to release mercury? Was it our intention to cause climate change? Was it our intention, to pollute the oceans? I mean, there's 6 times as much plastic as plankton in the Pacific Gyre north of Hawaii right now. I mean, did we intend that to happen? So the first industrial revolution was not designed. So when we call for industrial re-evolution, what we're looking at is to look at the whole system and say, if we could design a whole system of industry, how would we power it? How would we make things? How would we act? And that way we can have a vision toward which we can move a new industrial revolution. We're not asking everyone to become an expert at everything. We're asking everyone to understand that they could use the benefit of other people's expertise so that they don't become monolithic. Whereas what we're looking for is the best and the brightest coming together in multidisciplinary teams.
Implementing these ideas, we can design products that are continually recyclable and transform our current industrial system of take, make, and waste. Done intelligently, we would see as consumption increased, so would the health of the planet.
Well, it's all really common sense. I mean, every time we talk to children, they go, well, obviously. So the children get this immediately. It's the entrenched practitioners that have difficulty imagining doing something differently. How do we love all the children of all species for all time? That's the fundamental question. And can my design do that? Is it about love of all children of all species for all time? Not just our children, not just our species, and not just now. I consider myself just cosmic dust. Over 2 billion years we've aggregated into this form, and in the next 2 billion years we'll deaggregate into dust again. So it's really a question of the game. Which game are you playing? And for me, the game is a game that's optimistic and hopeful, because I don't want to play a pessimistic and a game of destitution. So I have to wake up every morning and be optimistic. I'm a designer.
Bringing the skills of an engineer to architecture and the vision of an architect to his work as an engineer, Werner Sobeck straddles two parallel disciplines whose ethical obligations intersect at material innovation, social relevance, and respect for the environment.
When the house was delivered, the steel structure, my wife called me up and they said, the contractor promised us to deliver the house today. What came around the corner is only a part of it. There's a little material on a big truck. You should call him up and tell him that he should deliver the rest latest tomorrow. So I called him up and he said, we delivered everything. It was all on one truck. It's just 10 tons. The primary structure is exclusively bolted. No welding, no gluing, nothing. But you may dismount the structure piece by piece and reuse the element or bring them to a recycling plant. So it's already from its conception a low energy building. Zero energy needed to heat or to cool the house. We provide our own electricity by photovoltaics. Yeah, we have our own fresh air supply. And we have no emissions. The building has no chimney. So it's the right thing to be placed on a green incline like this one. We have the luck here to live in the middle of the nature and to experience nature as changing of the light intensity, changing of the color of the light, laying in your bed and experiencing the snow flakes blown around the house. So this brings you very, very close to what's going on with you outside. And this is a very, very positive experience. What we did here is we transferred the transparency into the third dimension. So looking crisscross up and down diagonal through the building is, at least in my opinion, a big step forward, which comes very close to the living in a soap bubble, which I'm always intending. This question of how do we live tomorrow, how do we work tomorrow, or the day after tomorrow, this is simply the thing which interests me. And what is the architectural implication of those changes?
How will we live tomorrow? In R129, Sobeck explores the idea of completely living off the grid and in harmony with nature.
And this is really the first application of load-bearing glues in such a dimension. This is, by the way, the thinnest glass shell ever built. The thickness of the material is 10 millimeter in total, and the span is 8.50 meters, which is a tenth of an eggshell. It's paper thin. This, of course, is the first step to realize glazed elements, glazed shells in a diameter of 20 to 25 meters, as R129 is, but it is also an experiment to show that you can cover hotel atria, swimming pools and other things like this with a non-metallic enclosure.
The next idea would be to do a monospace which even has no furniture, where the furniture automatically folds and unfolds out of the floor or from the ceiling, where you have multifunctional furniture. Yeah, the place is simply empty. And then you make a kitchen out of it, or you make a living room out of it, or a sleeping place out of it. The next step would be just as an experiment, not as a must, but as an experiment to find out what would it mean if you do not have any contact with the building to the public supply systems, to the public grid. Means produce your own clear water, manage your own wastewater and so on, be totally independent, like a space station. The thoughts we have to develop there are the same as I mentioned for the next step for R129, independency from the public grid. So in our institute, we discuss these things, and we look below the stones and we turn the stones around, and we try to find out what is possible in a very radical approach. Not a research for this afternoon, a research for the day after tomorrow.
At the Institute for Lightweight Studies at Stuttgart University, Sobeck leads his students in a multidisciplinary approach, devising efficient and sustainable solutions for the building of the future.
We try to enable our students to manage the most complicated, to design the minimum weight structure, which is for structural engineers one of the most complicated things you can do. Isn't it possible that one element which is highly loaded to its maximum at one time and all the others are totally underloaded shares the job it has to do with the other ones by, for example, an artificial weakening of this highly loaded element through transferring loads to the underloaded ones. That if you do it in a clever way, you might save another 50% of material.
This is trying to show how efficient you could build using adaptive elements. And you have one support that's able to move, and you have sensors, and they're measuring the load of the train in every location. And the computer calculates how much this support has to move backwards and forwards to introduce a bending line, which is exactly the opposite of the one introduced by the train. So it always goes horizontally. So it's always showing the passive state, meaning without manipulation, and then coming back you have the active state, where you manipulate the system. What you do is you substitute material with energy. But what you can see here is you don't really need big movements in order to achieve a big change in the system.
If somebody comes up and says, how do I learn to design with a minimum material input? You won't learn that in the architectural faculty. Tell him to go to the aeronautics. He will learn it there. This is what I mean. Teamwork means a common language. And this is a question of education. Only. Bringing the students to the point where they understand what their basic discipline has to do and can do and where the limits are is the one thing. But what you have to do is enable the students to understand the neighboring disciplines. For me, everything installed in this nature is a piece of the built environment, needs a designer responsible for it, and you can't be responsible for a piece of the built environment if you are not educated to design it. Educated in the sense of make it stable, make it beautiful, make it recyclable, make it low energy or even zero energy and emission. If you really want to reach a goal, then you can do it. If you want to create something, there's always a solution. You just must to want it. This is what I'm telling the students.
For more information on this series, go to pbs.org. To order the 6-part DVD of Design E2, call PBS Home Video at 1-800-PLAY-PBS.